All right, to find the x-intercept of any function, Brooke.
Are we talking about, plug in 0 for y?
Perfect, perfect. We're going to plug in 0 for y. And my stylus is not working at the moment. Okay, we're going to plug in 0 for y. We did this last time. It worked for a second. How to find the x-intercept. Oh, it's my finger that's working. Plug in 0 for y. To find the x-intercept of any function, Ariana?
Sorry, plug in 0 for x and solve. Wait. Yeah, solve for y.
Yep, you got it. So the first one, to find the x-intercept, we plug in 0 for y. The second one, once my stylus starts working, I'll write it. But we did this in class last time. Come on, stylus. All right. Plug in 0 for x. Solve for y. All right, and then we find the x and y intercept, show your work algebraically. Did we do this on the board last time? Yes? No? You guys have this in your notes? Okay, so if you already have it in your notes, totally fine. I'm doing it again just really quickly because I'm actually recording a video this time since my player wasn't working last time. So to plug in 0 for y, there isn't a y here, but we talked about how f of x is the spot where the y would be. So we just do 0 equals 10x minus 1. We're going to add 1 to both sides. We're going to divide by 10. We get x equals 1/10. This is not how you write your answer. Yes, question? It's not loading. It's thinking about loading. Which Wi-Fi are you on? Okay, get off the student and try guest. Because from what I've heard, the guest one works better sometimes. When you guys type in answers into Canvas, we write this as an ordered pair. Now, I was grading some assignments last night, and I saw quite a few assignments where the person did not write intercepts as an ordered pair, got them wrong, but never went back to try a second time. Like if you're getting F's on your assignment, you should go back and fix your mistakes. Or if you don't know what your mistakes are, you should be asking questions. So I'm not giving you only one shot on those assignments. I mean, you could accidentally have some syntax errors and miss a bunch of questions, or like I said, put it as just 1/10, you're going to get it wrong. It has to be 1/10 comma 0. So I expect that if you guys get a low grade, you're going back. Now, if you only miss one question, you look at it and you're like, oh, I forgot a negative sign. It's not a big deal. You don't have to go back and redo the whole thing. But like those of you that are turning it in and getting 20s, you should be redoing it. Another thing you should know is that if you do redo it, you have to redo all the questions, which there's nothing I can do about that, unfortunately. It's the software, and I hate that, and I hate it so much. So that's another reason why, well, if you have a 95, do you really want to go back and do the whole thing? Probably not. Okay. But that's really up to you. The y-intercept, we've got, f of x, which is our y, equals, we do 10 times 0 minus 1. So f of x equals -1. And we write that as an ordered pair. 0, -1. Slope-intercept form, we've talked about that a bit already. Now we're going to talk about transformations that are in slope-intercept form. So this is what we started talking a teeny tiny bit, and that's why we needed to do more of it today. Today it's going to be all about transformations. We're going to transform lines and absolute value today. So anytime we have a vertical reflection, this is called a reflection in the x-axis. And I'll zoom in a little bit here. A reflection in the x-axis. Okay, I need to have everybody right now give me an x-axis with their arm. Everybody give me an x-axis. Let me see your x-axis. Is this an x-axis? No, give me an x-axis. X-axis. Okay? Now we're going to take some figure, we're going to put it right up here above the x-axis. Hi. Now what we're going to do is we're going to reflect in the x-axis. We're going to reflect in the x-axis. That means we're going to flip this like that. See? 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 Now you got to try it yourself or you're not going to remember. This is called kinesthetic learning. X-axis, arm, hand, reflect, reflect. Now while you're doing this, hey, look how dumb I look. Come on. Do it with me. Don't make me look stupid by myself. While you reflect, what direction is this going? Vertical. This is going vertical. But what words am I saying? Reflect in the x-axis. You see how they kind of contradict what you think? You always think y is vertical. But when you say reflect in the x-axis, we are doing a vertical transformation. Hey, while we're talking about that, everybody give me a y-axis. Give me a y-axis. This is called kinesthetic learning. Hi. Now let's reflect in the y-axis. Which direction are we reflecting? Horizontal. We're reflecting left to right. So it is reflect in the y-axis. Is this hard to do? Kind of like one of these things. Reflect in the y-axis is a horizontal transformation. It's important that you understand the difference between vertical and horizontal. This stuff that we are doing is the same stuff that we will do today through almost the entire year. So you've got lots of time to reinforce it, but if you get it right away, you're going to have really good grades the whole year because we do this over and over the whole year. So if I say a reflection in the x-axis and you don't remember if that's vertical or horizontal, you pull your x-axis out of your pocket and you say, okay, if I'm reflecting in the x-axis, that is vertical. Because see, I'm going up and down. Really important. All right, vertical stretch, vertical shrink. This should be common sense. If we have a vertical stretch, okay, I need everybody to stand up. Stand up. I'm going to put my mask back on. I should really pause this video. You can't see what I'm doing because I'm dancing. Oh, shoot. Translation, the word translation. Oh no. My stylus stopped working when we were dancing. Where? Where are you looking? Nothing clicks. Because like there's these buttons on my stylus and oh, now it's working. And I don't know what the buttons do. So, and I don't have the packaging to read. And there's no like name of who makes the stylus, so I don't even like know how to look it up. Okay, so anyway. It's working right now. Okay, so when we talk about vertical translation, we are talking about moving up or moving down. That would be like on an elevator going up floors or going down floors. Now here's the hard part. You have to use the correct terminology, the correct vocabulary when we learn this stuff. So I'm pretty sure all of us can take something and move it up 3 steps, 3 spots. I'm pretty sure we're okay with that. But can you tell me that was a translation up 3 units? So you're going to use the correct vocabulary. Okay. So last time we were graphing, I think we did number 2 and number 4. Is that correct? Number 2 and 4. So I'm going to go do number 3, since we already did number 2. So number 3, we are graphing which one? We are graphing the original function in red and then the new function in blue. So if you are using Kami right now, then you have lines, and you can just grab a red line. Y equals X goes through the very center of the graph. Y equals X is where Y and X are the same ordered pairs. This is the parent function. Okay? This is how all lines start out. And then as the line has babies, the babies aren't exactly the same, but they have a lot of things in common. So this line had a baby. And this is the equation g of x, 1/3 x minus 4. That's the equation of the baby. So I'm going to start out, and this is what we're learning today. It was not what we were learning last week, but we didn't get all the way through our notes last week, so I'm going to start out and show you a table. So 1/3 x minus 4. What I'm going to do in my table is I'm going to start out with -2, -2, -1, -1. 0, 0. You know what? I'm going to rewrite that in red because that coordinates to the red line, not the blue line. I'm rewriting the same thing if you're not using the same colors. Okay, so that is the equation points of the red line. I mean, there's way more points on that line, but this is just a select few that are very convenient. Some negatives, some positives, and 0. Now what we're going to do is we're going to use transformations. This is what we're going to do this entire year. We're going to use transformations to find the new graph, the g of x graph. So what we have to do is we have to decide what kind of transformations are happening. And this, it says it to write it underneath. You can see there's 2 transformations. For me, it's hard for me to write it underneath and see the line at the same time. Oh, you guys probably too, but I want mine to be big enough for you to see it. So I'm just going to write them up here, if you don't mind. I'm just going to write them up here. But it's just what goes underneath, just so you can see it better. Okay, so the 1/3 is a number that is being multiplied by the x. So we look at this table, and the a value, the thing that's being multiplied by the x, which we know is the slope, that is either a vertical shrink or a vertical stretch. So then we use common sense. If the number is 1, it is the same slope as the original y equals x line. If it is less than 1, then it is, if it's less than 1, it is a shrink. If it is greater than 1, it is a stretch. Those are common sense words. Stretch, bigger. So 1/3 is our number. Is that going to be a stretch or a shrink? Macy. The 1/3 that I have in that equation below, is that going to be a stretch or a shrink? Is it bigger than 1? No. So it's not going to be a stretch. It's going to be a shrink. Yeah. Not bigger than 1. So we're going to write vertical shrink. Oops. Okay, I just spelled that wrong. Fix my spelling. Factor of 1/3. So we're saying that it's a vertical shrink, and we're saying what the shrink factor is, 1/3. The other thing is subtracting 4. If we subtract 4, that brings it down 4, but we use vocabulary, translate, down 4 units. So we have a vertical shrink, factor of 1/3, translate down 4 units. So in our table here, we're now going to take this red function and we're going to apply order of operations to it. Out of these two transformations, what comes first? Multiplying by 1/3 or subtracting 4? What comes first? Order of operations. What comes first? Multiplying, subtraction. Warren. Multiplying, subtraction. What comes first? Yep, multiplication. So in our table, to the y values of the parent function, we are going to multiply each of them by 1/3. So I'm going to take -2 and multiply by 1/3, I get -2/3. I take -1 and multiply by -1/3, or by 1/3, I get -1/3. 0 times anything is 0. 1 times 1/3 is 1/3. 2 times 1/3 is 2/3. So I multiplied everything by 1/3. Then we are going to translate down 4 units. So after I multiply by 1/3, now I'm going to subtract 4 from that answer, that previous answer. So -2/3 take away 4 is -4 and 2/3. -1/3 take away 4 is -4 and 1/3. 0 take away 4 is -4. 1/3 take away 4 is -3 and 2/3. And 2/3 take away 4 is -3 and 1/3. Our x values never changed. Our y values changed twice. You use the outermost x's and the outermost y's, and those are your new ordered pairs. So I'm going to go back to my graph, and I'm going to graph -2, -4 and 2/3. Oops. You don't have to write this. I'm just trying to be so obvious what I'm doing. I'm graphing -2, -4 and 2/3. I'm graphing -1, -4 and 1/3. So -2, 1, 2, 3, 4 and 2/3. -1, 4 and 1/3. 0, -4. 1, -3 and 2/3. 2, -3 and 1/3. And I tell you what, that was a really long way of graphing a line. Because what other method do we know for graphing a line? Besides now making this table and doing a bunch of transformations to each value, what other way do we know for graphing a line when it is in the form of mx plus b? Tessa.
Plugging in 0 for x or y.
Finding the x or y intercept. Okay, so if I plug in 0 for, let's do 0 for x. It's not m. 1/3, 0 plus b. Nope, not plus b, plus -4. Sorry. We get the x-intercept is negative. Sorry. Did I do the wrong one? I did it in the wrong spot. Gosh. Does, in Kami, are you able to, like, select, I'm erasing it now. Are you able to, like, select stuff you wrote and drag it somewhere else? Okay. So you just got to erase. So 1/3 times 0 minus 4. So that's 0, -4. We can find the y-intercept. The x-intercept, we could do 0 equals 1/3 x minus 4. So 4 equals 1/3 x. Multiply both sides by 3. X is 12. And that's not even going to fit on my graph. I can graph it out here. It's not going to fit on my graph. What else could I do if it's in y equals mx plus b form? Amar, if it's in y equals mx plus b form, what could I do? Okay, I'm going to emphasize the word again, or what I'm looking for again. If it's in y equals mx plus b, what also could I do and find and do with it? What is the 1/3? The slope. I could use my slope from my y-intercept, and I could go up 1 over 3, up 1 over 3, up 1 over 3, up 1 over 3. So why are we learning the other way? So why we're learning the other way, this table thing, is because we're going to use the table in every section we do, and the majority of the year is not lines. So we're just introducing it with lines so that you've seen it with something that you've already done a lot with. But this year it's going to be done with all kinds of fun shapes. Okay, I'm going to do number 5. That one's a lot like this one. Actually, maybe we... Let's just talk about the transformations. For number 5, I would just graph it using y equals mx plus b. That's how I would graph it. I'll do the table again with the next example after 5, because the table we're going to use for different kinds of graphs. But let's just talk about the transformations, the new stuff here. Okay, for this one, the slope is negative 1/4. The y-intercept is 0, 1. And then using my algebra to find the x-intercept, I get 4, 0. So we've got the y-intercept is 0, 1. Our slope is down 1 over 4. Our x-intercept is 4, 0. Let's talk about the transformations. You just write it under the graph, but for me, I'll just write it here because I don't want to zoom far out since you guys are looking at mine. So we actually have 3 transformations. It has 3 blanks down there. Is that correct? It's got 3 transformations down there. Okay. The 3 transformations would be everything that is not y equals x or f of x equals x. Everything that's not that makes transformations. So I have a negative sign. I have a 1/4, and I have a +1. We have 3 separate transformations. I'm going to start with the negative sign. The negative tells you we have a reflect. Oh, no. It unplugged a little bit. Jaden, you doing all right? Okay. I don't know what happened to my Cami, guys. Story of my life. Okay, the negative sign is a reflection in the x-axis. So that's in that little table above when we were dancing. The second thing, the 1/4. The 1/4 is a vertical. Okay, is it going to be a stretch or a shrink? Nina. It's 1/4. A shrink. Perfect. So we're going to say a vertical shrink by factor of 1/4, because that's what we're multiplying by. And then the third one is a +1. So we say translate up 1 unit. Okay, I gotta fix this because I can't even see the questions. Oh, technology's wonderful when it works. All right, you guys, that's pretty much what I wanted to cover last class. Now we're going to add on to it. Let's see if I can. What if I just close out of this and reopen it? Maybe that'll help. Okay, good. It worked. Okay, so now what we're going to do is we're going to look at absolute value. Does anybody know what absolute value looks like as a graph? Have we graphed those before in our previous courses? Maybe Algebra 1? Absolute value? Okay, so absolute value is a V. You can remember absolute value is a V shape because of the word value. See? Absolute value. It will always be a V. If it doesn't look like a V, you did it wrong. This has the exact same transformations as a linear does. But this time we're starting with a different parent function. So we're going to graph our absolute value parent function in red. I'm going to go ahead and put some points in. Our f of x equals absolute value of x. If I plug in -2, -1, 0, 1, 2, if I put that in and I do the absolute value is the distance a number is from 0. Distance is always positive, so we have +2, +1, +0, or only 0, +1, +2. So we're getting only positive answers out. When we graph that, it makes a V shape. If you're using your shapes to draw lines, then just draw 2 lines. Oops, that was supposed to be red. Draw 2 lines that meet at 0, 0. Absolute value. So now what we're going to do is we're going to do the function